In this video, I'm going to talk about how to apply cosine law. The goal is to use the cosine law to calculate unknown measure of size and angle in acute triangle. So these three statements, these cosine laws. So this is triangle ABC, and this ABC, the lowercase letters correspond to the angle ABC. So a squared equals b squared plus c squared minus 2bc cosine a, and this a squared, right, equals b squared plus c squared minus 2 times b times c, and then times cosine a, right? And for this, b squared equals a squared plus c squared minus 2 times ac and cosine b, this cosine. And c squared is the c squared, this side, equals a squared plus b squared minus 2ab cosine c. Okay, let's look at the first question. Show that the cosine law is true for all acute triangles. So the question asks us to prove the cosine law is true for all acute triangle. This is cosine law, right? So I write triangle ABC and three low letter keys ABC for side lengths, and this angle ABC. And then I know the a squared equals b squared plus c squared minus 2bc cosine a. They look like extension of the Pythagorean theorem, right? So I draw a diagram and then draw a line segment from A to D. This AD segment perpendicular to the BC. So this is height. I set it as h, and x for BD and y for the DC. So I use Pythagorean theorem. Okay. So in this triangle ABD, so I write right triangle, right? So triangle ABD, this is a right triangle, right? So it's h squared equals c squared minus s squared, right? So Pythagorean theorem, c squared, so minus s squared equals h squared. And in triangle ACD, right, this right triangle, h squared equals b squared minus y squared, right? So h squared equals h squared, the equal expression. So c squared minus s squared equals b squared minus y squared, right? So this is x, this is y, so I can write x equals a minus y, right? Okay, so it's substitute a minus y for x, so c squared minus a minus y squared equals b squared minus y squared, right? So I expand this a squared, right? A squared, right? So minus 2ay should be plus 2ay plus y squared. This minus, so it's minus y squared equals b squared minus y squared. So both sides has negative y squared, so cancel out. So copy c squared minus a squared plus ay equals b squared. So I rewrite c squared and keep left side. I move this two terms to the right side. So c squared equals a squared plus b squared minus 2ay. Okay, so to look at y, so y in this triangle, so this angle C, right? Y is adjacent side to angle C. So I can use cosine, right? So for y, we can say cosine C equals adjacent y over b, right? So y equals b times cosine C. So okay, I substitute b cosine C for y. So c squared equals a squared plus b squared minus 2a and times b cosine C. And okay, so c squared equals a squared plus b squared minus 2ab cosine C. See, this is a cosine law for this, right? So for rest of the two of them, like a squared, b squared, and we can draw a line segment from B to AC, and from draw a line segment from C to AB. That's perpendicular to the base, right? Okay, yeah. Yeah, let's look at the second question. Determine the length of CB. This is triangles ABC, and we know the angle A 58 degrees. We know AC 32 meters and AB equals 40 meters. So I rewrite, I just copy this triangle here. I label the this side, the side is A, lowercase letter A, right? So opposite side to A. And this is C, lowercase letter C, so 40 meters, and this lowercase letter B, and equals 32 meters. So the question asked to find out length of CB is find out A equals what? So we can use cosine law. So like A square, right? A square equals this square plus this square, right? Minus this 2BC and cosine 15.8. So the four measurement we know 3, so we can determine A. Okay, so let's get into it. So we write A square, the cosine law, right? A square equals B square plus C square and minus 2BC cosine A. Okay, we substitute the values. B square, right? B equals 32 square plus C square. C equals 40, right? 40 square minus 2 times B 32 and C is 40 and the cosine A is 58 degrees. So, and 32 square equals 1024, 40 square equals 1600 minus, so this is 2560 and times cosine 58. Okay, so this is 2624 minus 2560. Cosine 58 equals 0.12 and equals around 106.41. So A square, right? Both sides take square root. A equals positive negative 126.41 equals positive negative 35.6. Yeah. So we take positive. So A equals 35.6. Right? Negative, that don't make sense. So A equals 35.6 meters. That is CB, right? CB equals 35.6 meters. So we find out the length of CB equals 35.6 meters. Okay, let's look at the last questions. The posts of a hockey net are 1.8 meter apart. This is the net, and players try to score a goal by shooting the puck along the ice from a point that is 4.3 meter from one goalpost and 4.0 meter from the other goalpost. Determine the measure of angle that puck mark with both goalposts. I draw a diagram to simulate these situations. This CAB is 1.8 meter apart for a hockey net. Okay, this is 4.3 meters from one goalpost. Right, so this goalpost, and this 4.0 meter, another goalpost, 4.0 meter. So this C 1.8, and this B lowercase letter 4.3. So we know three side lengths. The question asks us to find out this angle C, right? So the angle that puck make with both goalposts. So in order to find out angle C, we can use trigonometric ratios, like primary, right? It's not a right triangle, and we can use sine law, but sine law we don't know the angles, so we use cosine law, right? So it's in here C square, right? C square equals A square plus B square 2AB cosine C. We know C, right? We know A, we know B, but we don't know C. So in this statement, there are four measurements, right? So we know three measurements. We can find the fourth. We know A, C, we know A, we know B. So we can find out C. So we can, we use this one. So I just copy here. C square and equals A square plus B square minus 2AB cosine C, right? So just substitute the values. C square, we know the 1.8 square equals A square, A equals 4 square plus B square, B 4.3 square times A times A. Yeah, 2 times A, 4. And times B. B is 4.3, right? And times cosine C. We don't know cosine C. So, and 1.8 squared is 3.24 equals 16 plus 4.3 squared equals 18.49 and minus this is 34.4 cosine C. Okay, so we move this to the left. So 3.24 minus 16 minus 18.49 and equals negative 34 4 times cosine C. Okay, so this side I calculate already is negative 31.25 equals negative 34 cosine C, and both sides divided by the negative 34.4, and so negative 31.5 over negative 34.4 equals cosine C. Okay, so this division equals 0.9084 equals cosine C. So C equals angle C equals inverse of a cosine, right? Cosine inverse cosine negative 0.9084. So equals 24.7 degrees. Yeah. So it's angle C equals 24.7 degrees. This 24.7 degrees. So the puck make an angle about 25 degrees with the goalpost. So we use cosine law and solve the angle we don't know, but we know the three sides. Okay? Okay, let's summarize these lessons. The cosine law can be measured to determine unknown side length or angle measured in an acute triangle. Right? This is a cosine law. You can use the cosine law to solve the problem that can be modeled by acute triangle if you can determine the measurement of two sides and the angle between them. For example, this one, right? The two sides, 18 centimeter, 15 centimeter, and the angle between them, we can determine x using the cosine law. Because s squared equals 15 squared plus 18 squared minus 2 times 15 times 18 and cosine 46. All three sides, right? If a triangle, we know all three sides, we can determine any angle, right? So for example, in order to determine the R angle R, so we use this cosine law, right? 2.3 square equals this 5.9 square plus 6.2 square minus 2 times this one and cosine R. And for measurement, we know 3, so we can find the angle C, right? An acute triangle can be divided into smaller right triangle by drawing perpendicular line from vertex to the opposite side. You see this, right? Drawing perpendicular line from this vertex to the opposite side. The proof of the cosine law involves applying the Pythagorean theorem and cosine ratio to the right triangle. So we use this method to prove the cosine law, right? Okay.